Okay, welcome back to another Ramda video. In this Ramda video, we are going to talk about the function contains. And contains, let's actually start by reading the definition here. Contains returns true if the specified value is equal in R.equals terms, right? So that's how we determine equality, to at least one element of the given list and false otherwise. So, I mean, the question is just, I have this collection, I have this list, and does this collection contain this particular item that I'm looking for? That's the question, right? And if you look at the type signature, that actually makes a ton of sense. We're passing one item, which is the thing that we're looking for, and then we pass a collection or a list of things of type A here. And the question is then, does this list contain this particular item that I'm looking for? And then what we get back is a Boolean, right? Then of course we have this these arrows step by step because it's a curried function, right? So when we just pass the item, we get back a function that expects a collection, and then when we pass the collection, we then get back a Boolean as to whether that answers whether the collection actually contains the item or not, right? The interesting thing about this though is as they are saying here in the documentation, that equality is specified in R.equals terms. And very briefly, kind of, this actually just means that equality is determined. I mean, let's pause for a second. I mean, why are we talking about equality here? Equality matters because to answer whether a list contains a particular value, we need to be able to determine equality. I mean, if the list contains the value, or let me actually say, if the collection contains the item, then the item must be equal to one of the items in the collection. Like that's like part of the definition of containing, or of contains. So then we must be able to determine equality. So then the question is, on what basis do we determine equality? Do we say like JavaScript equals? Is that the way we determine equality? Maybe JavaScript has like triple equals, I guess. I can't remember, but if it does, then maybe that's the way we determine equality. But actually here they're saying it's none of these. What they do is they define it or determine it in terms of R.equals terms. And let me see, we haven't talked about equals yet, but we might just glance at this. But presumably what this is, or the essence of R.equals, is probably that it determines equality on the basis of, or rather on a value basis rather than on a per reference basis. So if you think about it, let's jump into Node here, right? And then let's do something like, I mean, if we say, does 1 equal 1, right? Of course it does, right? It says true. Does 1 equal 2? No, it doesn't, right? But then the question is, what if we have this object that has this key called foo that's equal to 1? Does that equal another object that also has the key foo that also equals 1? Or let me be more precise. We have two objects, one here and one here, and both of them contain a single key, foo, like spelled the same way, and both of these keys point to the same value, a single one. Actually, sorry, pause. Let me just let the cat in. Wow, sorry, I'm so confused. I thought it was the cat, but it was actually not the cat. Let's continue. So the key foo here is the same key as in, or the key, the first object has a key called foo pointing to a value of 1, and the second object has a key of foo pointing to a value of 1, and none of these two objects have any other keys. So in some sense, from a value perspective, these are equal, but in JavaScript, they're not equal, right? Because they have different locations in memory, right? On a per reference basis, they are different things. Right? And I mean, this is probably maybe hammering in the point too much, but let's say if we have O1, which is equal to an object which has the same structure that we just used now, right? And then let's say O2, I should have used let here instead so I can change these, but whatever. And let's construct O2, which contains an object of the same structure, right? Then we can say here as well, does O1 equal O2? Well, of course not, right? As we just talked about. I'm doing exactly the same thing, but we just put them inside of variables. Okay, of course they're not the same. But what we could do is, of course, we could say, well, O3 is equal to O1, right? Now, okay, O3, does that equal O1? Yeah, it does, right? But does O3 equal O2? It doesn't, right? So O3 equals O1 because they point to the same location in memory, right? Like the reference, on a reference basis, they're equal. They refer to the same thing. So JavaScript is, let's say, oblivious to the fact that that O1 and O2 actually have exactly the same structure. From a value perspective, they're the same. And in functional programming, we tend to be much more focused on whether things are value equal rather than reference equals. Because in some sense, it doesn't really matter, right? It's this whole equality thing. What does it matter that this points to this thing and this points to this other thing if they're just the same? Like structurally, they're exactly the same. So think about, let me put it this way. If you think about purity, for example, right? When a function is given some particular input, it should always yield the same output. And if two inputs are structurally exactly equivalent, like structurally equivalent, what's the rationale for that function behaving differently in the two cases based on the fact that these two objects or these two things that we're passing are pointing to different places in memory, right? If they're structurally equivalent, then like from a purity perspective, unless I'm completely mistaken here, but theoretically it seems like that makes sense to me. Then of course the function should yield the same result because these are the same thing. Structurally, these are the same thing. So there should be no difference in terms of the output. But anyways, okay, now I'm trailing off, right? So JavaScript behaves this way, right? JavaScript deals with reference equals. But now let's import Ramda, right? Require Ramda, and I'll put this in R. So let's just make sure that we have R here. Now we have all the functions, right? We can actually, let's actually jump to equals here, right? So in the documentation, I'll jump to R.equals, and we can see here that what equals does is that it takes one thing of type A, another thing of type B, and it returns a Boolean, right? And actually, sorry, now we're jumping ahead. We'll maybe explore this again when we get to equals, or maybe I'll skip this because if I remember that we've already talked about it now, I'll try and skip this. But let's quickly read the definition here as well. It says returns true if its arguments are equivalent, false otherwise, clearly, right? But interestingly, it handles cyclical data structures, right? So you can have arbitrarily deeply nested objects, compare them, and if they're structurally equivalent, like on a very deep level, they could still be equal, right? This you can't do in native JavaScript, and writing that function is actually a bit messy. And this is just, it says that it dispatches symmetrically to the equals methods of both arguments if present. I'm not actually sure what this means. Dispatches symmetrically to the equals methods of both arguments if present. I'm not sure what the symmetrically part refers to here, but equals is of course that if you pass objects that implement an equals instance method, then our Ramda's equals would dispatch to the equals methods of those objects. So if you would try to compare two instances of classes that implement a method called equals, then Ramda will dispatch to those methods instead of trying to compare them like on its own, right? Because if you have your own class, how would Ramda know how it's going to compare these? So probably we'll return to equals when we get there in this video series. But now let's, I guess, go back, right? That's equals. So now we know the type signature of equals, so we can actually run equals, right? So let's say equals 1 and 2, let's say, okay? This is false, of course. Sorry, let me make this text a bit bigger, like so. Yeah, that's not a lot. Okay, like so. But then if we say equals 1 and 1, yeah, that's true, okay? And now, what if we say equals O1 and O2? That's true, right? But O1, in like plain JavaScript, if we just say equals O2, that's false. Because they're not the same place in memory, they're not reference equal, but they're structurally equivalent. Now, let's say that we have O4, right? Which has the same, actually I've forgotten what was the structure of O1. So that's the structure of O1. Let's now create O4, and let's say that has the key foo pointing to 1, but it also has the key bar pointing to 2, let's say. Okay, so O4, that's the structure of O4, that's the structure of O1. Does O1 equal O4? Still, of course not. I mean, now we're just using plain JavaScript, but then we can say, does R equals on O1 and O4, are they then equal? No, right? Because O4 contains additional keys. So O4 without the key bar, like O4 without this portion, that would equal O1. But O4 as it currently stands does not equal O1, right? But anyways, that's the way R.equals works. So now we can actually understand contains, because contains is just R.equals applied across the whole list, and we're reducing down to a single value, which is true or false, depending on whether any of the items in the list actually match the thing that we're checking. So now we can say something like R.contains, let's say, I mean, let's do something simple first, right? Let's say, can we find the number 10 in the list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? Why did I choose such a long list? Anyways, okay, it contains it, right? But what if I remove it? Then we get false, right? Simple contains, okay? But we can also do this, right? We can also say, do I have, actually let me do, or yeah, let's hard code it first. So can we find an object with a key called foo pointing to the number 1 if we are searching, how to do this, right? If we're searching through the list containing a number of objects, let's say first an empty object, then an object containing bar pointing to 2, and then an object containing foo pointing to 1. So the answer here should be true. Oh, syntax error. Ah, now the cat actually wants to get in. Apologies, wait. Let's continue. So, what was the syntax here? I'm missing a parenthesis, I guess. No, sorry, we're missing this square bracket for the array. So then we can see we get true, right? And what if we remove this item from the list? Of course, we then get false, because now the list doesn't actually contain this value. And what if we go here, back to this example where we did have it, but we change this object so that it as we looked at before, also contains another key which points to some other value. I mean, it doesn't really matter that it points to another value, but it matters that now this object here is not structurally equivalent to this object here. So then, of course, the answer should be false, because now the list doesn't actually contain the thing that we're looking for. So let's run that, and we can see, of course, we get false. So that's very good. Okay, and let's try to do this using our previous variables, right? So let's say contains, and then let's say O1, right? So can we find O1 in the list of, let's say, empty object, empty object, empty object, just to put some stuff in here, and then I will put O1 here, and then we'll close that, and we'll close that, and of course it does contain that. Doesn't matter if we choose O2, doesn't matter if we choose O3, but actually O3 is actually reference equals. But if we choose O4, it doesn't contain that, because this is the structure of O1 and this is the structure of O4. So yeah, I mean, I would guess that actually makes sense. You probably see how this is fairly kind of makes sense, right? And because it's using R.equals, again, like we could actually do this arbitrarily deep. So I think that's actually what they're showing here in the example that they have here, where they're saying, can I find the array? No, that's actually not a question of nestedness. That's more a question of, you can actually also search for lists, of course. So you could say, can I find the list of 1, 2, 3 in the list, in like a list of lists, right? In this list of, let's say, the list of 1, the string foo, and the list, let's say 1, 2. Actually, let's just stop here, right? This is false because it doesn't contain. But if we put 3 here as well, now this long list actually does contain the list 1, 2, 3, right? Because it's here. It contains the list 1, 2, 3. But let's also, before we wrap this up, let's also do something where we have something which is more nested, right? So yeah, let's just code it up like this, right? Let's say we are looking for an object which has the key A pointing to an object with the key B pointing to the value 1, right? So you can see how we have a nested object. Actually, let's put this inside of a variable. So let's say n1, I'll use n to denote nested, right? So nested object 1. Did I do this? Yeah, I think I did this correctly, right? And you can see this is the structure of n1. Then let's say we have n2, and let's build up the same structure. A pointing to a new object where we have a key called B pointing to the value 1. Let's close this and let's close this. And then we have n2, and that's the structure of n2. And you can see, like, just looking at these two, you can see that clearly they have the same structure. From a value perspective, they should be equal. And then let's do n3, and let's do something else then, right? Let's say we have A pointing to B pointing to 2 this time, okay? So n3. And now you can see this is different, right? They have the same structure in terms of keys, but the value inside of this n3, of the nested object 3, is different. So these should be different, right? So let's say this, using R.equals, is n1 equal to n2? Yes. Is n1 equal to n3? No. Right? Because it's recursively searching down this object, or it's recursively exploring the contents of this object and realizing that they're not actually equal. Which means that because they're not R.equals, a list, we could also make use of R.contains, and they would not turn up as equals in R.contains. So can I find n1 in the list of n1, n2, and n3, let's say? Okay, yes I can, right? But I mean, that's kind of trivial because I put n1 in this list. But if I put n2 and n3, yeah, it's in there, right? But if I remove n2, it's no longer in there because n3 is not actually equals. And this probably works as well with nested lists, right? So if we say R.equals, let's say a list of a list of a list of 1, like so, and then a list of a list of a list of 1. Did I miss one? No, like that. That's true, right? But if I change this to 2, that's false. So then this would work the same way. We could say R.contains, and I have a list. So this becomes a bit messy, right? But let me just try to space this to make this a bit more sensible. Like that, right? No, like this. So this list here, this list of a lot of nested lists, do contain this list of a list of a list of 1 because it's here, right? But if we remove that one, then we no longer have it because now this list of a list of a list of a list of a list of 1 actually isn't found in this list of lists because here we only have a list of a list of a list of 2. So yeah. But anyways, the point being, you can go arbitrarily deep, and now you can very trivially compare things on a sort of structure basis, on an actual value basis. And just to emphasize that this isn't completely, I mean, okay, it's somewhat trivial to recursively implement on your own, of course, right? I'm not saying it's complicated, but it's complicated in the sense that it's a lot of code, so you don't want to do this on the fly. So even if you would roll this kind of value comparison function on your own, you would want to put it in some kind of library that you would, not like an external library, you would put it in some kind of module that you would reuse across your code base so that you're not implementing it on the fly all the time. So let's actually jump to the source code here of contains. I think we can dig down. Oh, sorry, I've actually turned off my Wi-Fi. Let's hang on for one moment and see if we quickly get up there. Yep. Okay. So now we go to contains, and if the internet, yeah, okay. So, and you can see here, okay, so what's the implementation of contains? Well, it's just a currying around underscore contains. And where does underscore contains come from? It comes from internal contains. Okay, so we have to dig back, let's see, back to the source, into the internal folder, and we were looking for contains. Contains here, right? And that's actually just making use of index of, because if you think about it, I mean, you're probably familiar with the index of function of JavaScript, right? Like where we have, let's say 1, 2, 3, an array of 1, 2, 3, and you can say, what's the index of 2? Right? And you can say, okay, well, 1 is the index of 2. That's where we found 2. And then if you're asking for the index of, let's say, 10, which isn't in the list, you get -1, right? So they're doing the same thing here. They're just making use of their own version of index of, which is not reference-based, but which is value-based. And then if the index is different, or actually greater or equal than 0, then you've actually found it, and that means contains. But let's jump back here and let's look for underscore index of. Also in the internal, let's see, index of. And yeah, this is what I wanted to show, right? So I mean, I'm just emphasizing that it's not really trivial to actually implement this, because there's a lot of recursion, because you actually want to recursively determine whether something is equal or not, because you want to respect nestedness. So yeah, that's it's an important function to have if you're getting into functional programming, because probably again you'd be more concerned with whether two things are structurally equivalent, as opposed to whether they actually point to the same place in memory. All right, that is it. Thank you very much for watching. I hope this makes sense. Remember to subscribe so that you won't miss the next Ramda video, and I will see you in the next one. Thanks for watching.